Alright everyone, this semester I want to try and do something regarding making videos over content that it's a little bit more difficult. So if there's ever any content that you guys have specific questions on or want me to make a video on, just send it to me in an email, and if I have time I'll definitely make a video about it. And I'll also try to be proactive and make videos over content that I think that would be a little bit more complex. So for this chapter, I think one main thing is the positive versus negative feedback. So I figured I'd make a video about it. We'll start by talking about our positive feedback. So let's say we have our graph, and in the body we're always going to have a set point concerning values of importance. So this can be a lot of different things. This can be temperature, this can be levels of certain substrates such as glucose in the blood, it can be blood clotting, it can be applied to a lot of different concepts. In this case we'll talk about blood glucose. So in the body we're normally around 70 to 110. That's a set point. It's generally a range, not a specific value, because we know in homeostasis it's not going to be a set line. It's generally going to look something like this. We're going to fluctuate in between values, trying to stay in that range of our homeostatic set point. So things aren't going to be just set in stone and specific. They're going to fluctuate. So in this case, we're going to say that let's say we're looking at a person's blood sugar and they just ate a very sugary meal. They just had a big box of crumble cookie. We would expect their blood sugar levels to rise, right? Well, eventually this is going to surpass the set point range that the body has. And that's going to trigger reactions in the body. So if we look here, we'll say the blood sugar is rising, and then we're going to have a reaction. That's going to bring it back down to the set point. We can look at this graph and say, okay, well, this part right here that's going up, that's our reaction. And so if we go back to our definition of negative feedback, we know that we have our three-word definition was reaction, and you can fill in a lot of different words. I'm going to say negates stress. And sorry, I made a mistake. This is the stressor. So our stressor in this case would be elevated blood sugar that's caused by a sugary meal. Our reaction is what's going to bring, in the case of negative feedback, it's going to bring us back towards the set point. So our reaction is going to be this side that's going to be bringing us down towards the set point. So in the body, this can take the form of insulin. So we're going to have our pancreas. It's going to release our insulin. That's going to cause, let's say this is a cell, and these are all of our little sugar molecules. So we have excess sugar molecules right now. So what our insulin is going to do is it's going to allow these sugar molecules to be taken into the cell so that we can make glycogen in the cell. So our glycogen is going to be made in our muscle cells, our liver, and we're going to essentially use glycogen as a storage for sugar. We don't want a lot of excess sugar in the blood. So if we can take that into the cells, we can take that into the liver, we can make it into glycogen, then we can lower our blood sugar and we can form a store of glycogen so that whenever we need sugar, this can be broken down later on. So let's say, sorry. So our reaction brings us back down to our set point. Now, let's say that our body makes too much insulin, because we know that it's not just going to come down to the set point and then remain stable from there, right? That's not how the body works. Well, let's say we make too much insulin, and let's say our cells bring in too much sugar. So now we have too little blood sugar. Well, that would be a stressor. So our stressor is low blood sugar now. That's caused by excess insulin. So we're going to be coming down. We're going to reach a low blood sugar. once we surpass our set point range, let's say like a set point range right here. So we exceed that set point range, well, the body is going to then trigger its reaction to that because we want to get back to that set point. So we have our reaction, so remember stressor, and then reaction brings it back towards the set point. So reaction brings it back towards, and so on and so forth. And so the body's just constantly in this up, down, and maintaining our set point, and that is for negative feedback. And remember, negative feedback, this is kind of the main way that our body maintains its set points in homeostasis. Positive feedback generally is more negative. There are examples of positive feedback in the body, but we generally don't want our reaction to be amplified. And so back to our negative feedback. So our stressor, we have low blood sugar. Our reaction, let's say an example, as Dr. Taylor had mentioned, was glucagon. So glucagon is what I like to think of as the opposite of insulin. So insulin says, hey, we need to get rid of this blood sugar and we need to store it in the form of glycogen. Well, glucagon, it comes and it's going to reach into those stores and it's going to grab out that blood sugar. So it's going to cause these glycogen stores to be broken apart. So we break those apart and then we get our sugar molecule. It's going to have a phosphate on it. And then that can then be sent back out into the blood. If we need blood sugar, that can be used for cellular processes. If we need to enter that into glycolysis, whatever the case may be. But the key point is that glucagon is going to, instead of causing the uptake of sugar, it's going to cause the breakdown of sugar. So it's just the opposite process of insulin, and together these allow us to maintain this homeostatic set point. So now if we want to talk about a positive feedback loop, so we have our graph, we have our normal set point. Well, with positive feedback, we know that we still have our reaction and we have our stress and we have our reaction. Stress is always going to fall or be prior to reaction, so reaction follows stress. Well, in positive feedback, our reaction amplifies stress. So I wrote that backwards. So reaction follows stress, and in the case of positive feedback, reaction amplifies stress. You can use a lot of different words to describe, but the key is that reaction amplifies stress, reaction increases stress, reaction essentially causes us to deviate further from the set point. So the stress causes the initial deviation. So in class we went over hypothermia. So your body temperature, let's say you're 98 degrees, well, you're in a very cold environment, and this can also work for hyperthermia. So if we know hypo and hyper refers to high or above, hypo means low, so combine the words. Hypothermia, thermia is temperature, so above temperature, below temperature. And so in the case of, let's say, since we did hypothermia in class, let's do hyperthermia. So you're at a normal temperature, but let's say you're outside, you're working, you're sweating. Your body's going to try and maintain your set point. So we're going to initially have negative feedback reactions. So we're going to sweat, we're going to vasodilate in our skin. That's going to try to maintain us at this set point. However, once we've been outside for so long and we've been exhausting all of our homeostatic mechanisms that are going to keep us at this set point, eventually we're going to start to deviate and our body's not going to be able to compensate anymore. So instead of having that up and down that we had in negative feedback, at a point we're going to get to the point where our temperature starts to rise and we're going to start sweating less. So let's say we start sweating less. And because we start sweating less, well, now it's hot outside, we're sweating less, which was one of our cooling mechanisms. Our temperature is going to continue to rise. And let's say we get to the point where, okay, the body's like, hey, we're in trouble. When the body starts to get in trouble, it starts to vasoconstrict. So vasoconstriction is just referring to our vessels. So our vessels are going to constrict and start shunting blood towards the middle of the body. Well, once they start shunting blood toward the middle of the body, as we had talked about with a negative feedback for high temperature, we know that in the skin, our vessels actually vasodilate, meaning that they increase in size. By increasing in size, they can give off more heat, which allows us to cool ourselves. But once they start vasoconstricting, we stop sweating. At a point, you're going to eventually stop sweating completely. Your body's going to start vasoconstricting in the skin. So we stop sweating, we're vasoconstricting in the skin. We're just continuing to deviate from that set point. Eventually, we're going to reach our threshold to where we can no longer compensate. Once you pass this, as Dr. Taylor had mentioned, it's essentially like jumping off the cliff. There's no coming back from this point. So this is where you would reach like heat stroke. So you reach heat stroke unless another person or rapid interventions are done. Pretty much from this point on would be death, permanent damage, stuff like that. So generally, positive feedback is not good. There are examples of positive feedback that are good, like blood clotting is an example of positive feedback. We don't generally want to be making blood clots all the time, but if you're in a very traumatic accident and you're bleeding and you need to stop that bleeding quick, then the actual positive feedback that occurs in blood clotting is very beneficial to the body. Same thing with pregnancy. When you're giving birth, the actual dilation is an example of positive feedback. So as you begin to dilate, it essentially triggers you to dilate more to facilitate birth. But generally, in just overall homeostasis, negative feedback is associated with positive processes. It's associated with maintaining homeostasis, and a lot of times positive feedback is going to deviate from that set point, which is generally not a good thing. But yeah, I hope to see you guys tomorrow. If you guys have any questions, please don't hesitate to reach out. Thanks.